So we're told here that we have a car completing around a track. So we could draw a track. So we have a car completing one lap at an average speed of 50 meters per second. The car completes a second lap at an average speed of 100 meters per second. Explain why it's not 75 meters per second. All right, so a useful tool we have is we could make a graph, for example, a velocity time graph. And we know that we can read the velocity time, and the slope is the acceleration, and the area is the displacement. So we start out with a velocity of 50 meters per second. And we know that the area is the displacement, so that area is going to represent the distance around the track. Now we know also then the average velocity during the second portion is 100. It's twice as much. But the displacement is going to be the same. That displacement, meaning the same area. Aha. So what we can see is that traveling at twice the speed requires half the time to complete the lap. Okay, so this 75 meters per second is the result of, if we did this, v bar equals v plus v0 over 2, which is 100 plus 50 over 2. And that gives us 75. But this formula requires something. It requires that the acceleration must be constant. It must be constant. And if we look here, the slope, in this particular graph, the slope is like infinite. We see an infinite shift. And if it's not the infinite shift, then we would need, say it constantly accelerated through the second half, then it would need to have done this, so that this area over here equals this area. But in either case, in none of those cases is the acceleration constant throughout. Here the acceleration is 0, and here it's this number. And even if we did a similar thing, if we said, we had an acceleration like that, well, then this one would need to be like that. You could see that the accelerations, the slopes, would not be the same. So, explain why the cart's average speed for both laps is not 75 meters per second. So, for fact, we could start out by saying that the value of 75 meters per second comes from an average of the two speeds of 50 and 100. One can only average the speeds if the acceleration is constant. It is impossible in this scenario for the acceleration to be constant. Over 2 laps. Therefore, the 75 meters per second is false. So we go in here and identify our fact statement. One can only average a speed if the acceleration is constant. This is also a fact. or it's a factual observation. So maybe we'll say this is the observation. There's the fact. And it's impossible for this acceleration to be constant over 2 laps of equal distance. Therefore, the 75 meters per second is false. What this calculation to get 75 meters per second is an average of the speeds. And what we can see is the second speed is not traveled at for the same length of time. Is the average speed for both laps closer to, greater than